In this problem, we want to determine the magnitude of the resultant force of these two forces added together, F1 and F2. Now these are in 3 dimensions, so the way we're going to start this is write each force in Cartesian form, and then we'll sum up the x, y, and z components to find our resultant force. So we'll start with F1. Okay? And F1 is only in the x direction and the negative z direction. Okay, so it's 300 cosine, because it's adjacent to the x-axis, cosine of 30 in the I, 300 cosine 30i. Nothing in the j direction. It's lying in the xz plane, so there's no component in the y direction. And then I've got a negative k of 300 sine 30 given there. Okay, and then here are the numbers for that calculated out. Okay, moving on to force 2. Now this is actually done in 2 steps. Okay, so you notice I've got a light blue triangle and a dark blue triangle. Okay, the light blue triangle lies in the xy plane, and the dark blue triangle is basically a vertical triangle. This line right here on the edge of the dark blue, that is in the z direction. That is f sub z. Okay, so if the hypotenuse of this right triangle is right here, that is 500. That means the fz component is opposite that, so it's going to be 500 sine 45, and that's in the negative z direction. So you see right here we have the 500 sine of 45. Again, that's this line right here. Now this side of the triangle, of the light blue triangle, that's my x component of the force, and this is the y component of the force. Okay, this is the hypotenuse of that light blue triangle. It's also the adjacent side of the dark blue triangle. So the length of this line right here, which is the hypotenuse of the light triangle and the adjacent side of the dark triangle, this is 500 cosine 45. Okay, and I get that from this 500 newtons. Okay, it's adjacent to the 45, so that's 500 cosine of 45. Now I use that hypotenuse to find the x-axis, which is opposite of the 30 degrees. Okay, so I'm going to take that value, the 500 cosine 45, times the sine of 30, because it's the opposite side. And that's what I have right here. 500 cosine 45, that's this line right here for the dark blue triangle, times the sine of 30, because the x component is opposite of that 30. That makes this side 500 cosine 45 times the cosine of 30, because this one's adjacent to the 30. So again, what I have here is 500 cosine 45. Again, that's this leg of the triangle. Okay, that I get from the F2's 500. Okay, then cosine 30, because the y component is adjacent to 30 here. Okay, and that's in the j direction. Okay, so I have those, and I can calculate those given right here. There are the numbers for F2. So now I've got the F1 and F2. Now, in order to find the resultant, I simply sum up my i's, sum up my j's, and sum up my k's, as shown here. So here, here's F1 calculated up here, and here's F2. So I, take I plus I, 0 plus this j, and then this k plus this k, and I get this as my resultant force. Okay. Then to find the magnitude of that resultant force, I just use the square root of the sum of the squares. So square root of x squared, y component squared, z component squared. There should be a little plus sign in here. It's a little typo here. Okay, so plugging that in here, I determined that the magnitude of the resultant force is 733 newtons. So again, I just break my forces up into Cartesian form, sum up my x's, sum up my y's, sum up my z's, and then square root of the sum of the squares to find the magnitude.